So here we can see the site stopping distance is 33. If I change the design speed up, that distance goes higher, and now I see that I'm going beyond my road class, which I said was 30. Let's go back to 30. If I make the K factor small enough, again I get an error, and at some point I should get the error that I'm exceeding my road class, my site stopping distance. If I type in a small enough distance here, no, big enough distance, sorry, let's say 100, then I get an error that says K is too small for site distance. Okay, so you can be more sophisticated if you want, and the same is true for horizontal curves. So if you're working on a road that you really have to know how fast you can drive around these corners, now that I'm in advanced mode, if I take a look at a curve here, it's telling me, okay, we're outside super elevation table. Well, that's because we've got such a small design speed. But if I increase that, then I get this warning, but that's okay. It's telling me that I'm now on my table, and it's calculating the super elevation for me. And you'll see that if you look at the cross sections, that there's super elevation in the cross section as well. Oh, that doesn't look very super elevated. Why is that? Yeah, it is. Sure. -2, -2. Okay. So there's lots of different ways to approach the problem. The problem with low volume roads is that there are, you know, very low volume roads, and then there's sort of maybe a mine access road or a main line in a forest, in a logging project. You're going to have to design a road that drives a little faster. So you may or may not be interested in using curves. Let's take a look at a really very simple low volume road. I'm going to use this to introduce the survey map module. Okay, so survey map module, what's it good for? Well, let's take a look at an example survey. Here we've got a very simple table of, well, let's just go through it. Azimuth, slope distance, percent slope, side shots. What are side shots for? Well, they allow me to define what the cross-section looks like. -25 on the left, +40 on the right, and in this case there's actually a break point here where it changes. Okay, so I can put in side shots. Here's the simplest side shot you get, just a slope. And you can put in compound side shots if you want that are more complicated. You can also put in materials in the ground. You can say, well, we've got this material, and then when you go down a certain depth, we got that material, and then we got some other material underneath. You can leave that blank if you want, or you can fill in reasonable data. And you can also put in where you think there's going to be a culvert and what diameter you think the culvert would be. So as you're walking through the woods, whoops, wrong way. I wanted to do that tile vertically. And there's a question from Sean and Galen. I'll get to those in just a sec. You can see your traverse growing as you enter your notes, and those blue things are culverts. So this is for low volume, simple paper note survey, or using our handheld in the field. It's a Windows CE handheld device. And now that I've got this information, I can actually generate a surface from this, or I can go right into the location module and build a road on it. So simple slope distance, azimuth, percent slope, done with a compass or Clino, and chain, and side slopes, probably done with your Clino and chain as well. First, let's look at these questions. Software works in both metric and imperial units, and yeah, you can work either way. And there's some conversions for going between if you ever have to do that. In fact, there are there is the ability to set up various projections and to convert between projections. So if you're working in UTM coordinates, you can work in UTM coordinates, and then you could convert the data to, in BC, people use Albert's equal area projection. You can convert between the two if you need to. Often people work in simply undefined, meaning we don't care what projection we're using. We're just using a consistent coordinate system where everything ties to everything else. And you can tie surveys to other surveys. You can tie them to well-defined points. You can tie them to GPS points. So you can get your traverse, even though it's done with simple, low-tech survey instruments, you can still tie it down to the Earth using a GPS or other methods so that you're working in real-world coordinates. Next question. Somebody's getting a little bit ahead of what I'm showing at, which is the station yard haul distance times volume. We'll get to that, and yes, we can calculate that. And for the survey module, yeah, this is all completely configurable. I think you can even drag these around to change the order. You can change the order. You can also add columns that are custom made for your own data. And you can remove columns that you're not using. And you can change which column goes to which when you hit the Enter key. So right now I'm set up to enter a label and then what type of shot, and then azimuth, distance, slope, side shot, material. And then it's asking me, is there a creek? No. Is there a label? No. And then back to the next shot. Okay. So this is an option. Once we've got our data into this file, we can go over to the location module, and we can create a design using the side shots as cross sections. The other thing we can do is we can go to the terrain module, and we can read in the survey with side shots and create a surface. I'll just show you one. I won't go through the details, but essentially those side shots do define. Okay, we're in the right. Yep, here we are. Forestry, that one. Yeah, as you can see, there's a feet one there. Yeah, so we do it in feet or meters. Here's a surface that was created, and you can see it's a reasonable surface. It's kind of clunky and choppy because there aren't a whole lot of data points. This was created by taking the survey information, which looks like this. You can see there the center line and the cross sections, and creating a surface from it. Now, in fact, you can get better surfaces, even from a very simple survey with side shots, by including some extra data in your survey. You can create things called reference shots, which can go out in any direction. There's one. Let's just turn that on. Section lines, radial shots. Okay. So there's my section lines, and that's the radial shot right there. I just clicked on it so it becomes the current point, and there it is. So azimuth, slope, distance, it's created a 3D point. And you can create as many of those as you want. So in an area where you want to define the three-dimensional surface better, you can create a bunch of radial shots. When you bring that into terrain, you get a better surface because it uses those 3D points. Okay, so I can create a 3D surface from my survey with side shots. And now I'm going to create a location design. So we've done our paper notes. We've typed them into the survey module. We've built a surface. Now I'm going to create a road. So File New, and the first thing it asks me for is, where's your original ground? And I'll just find that quickly. It's in my example forestry section. There's the survey with side shots. There's the terrain file. I pick them both. You can choose either one or both. And I'm now creating a brand new location design. And the nice thing here is that, first of all, it follows the survey that you created. That's the initial, in both vertical and not in horizontal. No, I mean in horizontal, not in vertical. Okay. Got a question from Michelle. She's asking about tying traverses together, and will the coordinates match? And absolutely, that's the whole idea. When you there's two different ways of tying traverses together. One is by simply typing in coordinates, and that always works. You just go to the station you're interested in, coordinates set, and type in the coordinates. Okay, that's easy. But and you can copy coordinates and paste coordinates too, so it can be fairly quick to go into traverse number 1, copy coordinates, enter traverse number 2, paste. But we have this function here called, it's in the map module. You can add as many traverses as you want to your map, and then we have a feature called coordinate adjustment, which allows you to tie stations and reference points between traverses, and it does all the X, Y, Z adjustments for you so that everything is consistent. It's a little tricky, but it's a lot of typing in the coordinates. Okay, back to the location module. So I'm doing a super low volume design here, and I want to create a vertical alignment. Here's a completely different way of doing vertical alignment, and it's often done this way in the forest industry. What I do is I move along to my surveyed cross-sections. That's what these red tick marks are. And that is exactly the surveyed cross-section that I have in my survey notes. If I go back to that station, that's what you'll see. And then I just move up and down in the section window, and then double check that I'm not getting stupid grades. I'm not quite sure why I'm not showing the survey points, but that should have been turned on in here. So I say OK to that, and yeah, and now you can see all the points. Oh, but I'm not showing grades. Wait a minute, I got the wrong screen layout. Let's just go to screen layout called Profile. So you can see in my section window I've got side shot left, side shot right. I've got super, which is in this case just crown, and I've got grade next, grade last. Last is the important one, but it's also shown here. There's my grade. So let's do another one. So I'll skip ahead to the next survey point, that one, and I probably don't need to move it at all. But as soon as I move it, it creates a vertical alignment point. Now I can just go in here and click on any old thing and anchor down wherever I want, and I've created a grade. But I can also go to any cross-section and edit in the section window. So I can edit, add a known cross-section, and make sure that I'm still on the known cross-section. Or I can edit in the profile window, and then I can move any station I want, and I'm actually calculating a cross-section between two surveyed sections, so it's doing some sort of relation. Right, so that's often how forest roads are designed. And then they'll go into the plan window and say, yeah, you know, this is good, it's all good, I don't need to change anything. Oh, right here, what is the curvature here? Let's put in a curve. Or, you know what, we got it wrong here, let's move sideways a little bit and just tweak the horizontal alignment to change it a little bit so that they get what they want. Running out of time, I want to go to culverts and output.